Welcome everyone to my channel Simulation Engineer. So as you can see, as it is flashed on the screen, so the topic is random numbers. To be really precise, how you can generate the random numbers using numerical Python. So the numbers that cannot really be produced logically are called random numbers. It's kind of a crude definition of random numbers. And random numbers can be produced by using some algorithms, such as you can call them as pseudo random numbers. The use of random numbers can be utilized in NumPy, which is a numerical Python library available in Python via a dedicated module called random. So we can generate random numbers by using the numerical Python library. So before we really start with the real work, we need following modules for the random number generation, and to visualize we will see later on. So first of all, we will start with the generation of random numbers and then how to visualize different kinds of data distributions. So we will need first of all numerical Python. It's a NumPy library, and then the random module for random numbers generation. And then in order to visualize your data, we need another library which is called matplotlib.pyplot. And then last but not the least, Seaborn, which is a very important for plotting multiple plots and of very complex natures. We will see later on how we can compare different plots by using this Seaborn module. So what I'm using for demonstration purposes, as if you have seen my previous Python videos, I have already done just for an info a detailed tutorial on how to use Jupyter notebooks using Visual Studio Code with combination of Python and numerical Python. So this is an interface of an IDE which is called Visual Studio Code. It's a really free IDE or integrated development environment tool, and it's really very powerful. You can do all kind of programmings within this Visual Studio Code. So if you don't know where to get these tools, I will show you just so first of all, this is the website of Visual Studio Code. By the way, I will put all these links in my description box, so you can get it also from there. So code.visualstudio.com, and you can simply download it, and it's available for Windows, for iMac, and all kinds of different systems. I'm using Windows here, so I have installed the Windows version. Then, as mentioned earlier, this is the one which we will be requiring for our random number generation is numerical Python. So if you don't know how to install that, you can use it or install this numerical Python library using either Conda environment. If you are using really Conda, so you can use these commands to install it, or otherwise you can use pip. So I am using pip, so I have already installed that. By using pip, you can just open your Windows terminal, and if pip is already installed, make sure that this is really available in your computer system. And then this is the command to execute the NumPy installation. So that's the first one. And then the second one is the matplotlib library, which is very important for data visualization. And you can use the same process by using your Python pip install commands to install the matplotlib libraries. So once again, the last one, which is a Seaborn, it's a statical, as I mentioned earlier, data visualization library. You can see from the website, you can generate all kinds of very fascinating and interesting plots. And in order to install that, one has to go once again with the same approach. So if you are using a Conda environment, you can use Conda install Seaborn. But if you are using a pip environment, you can use pip install in Seaborn in your terminal, and you are good to go. So I think that's it as far as the tools required for the installation point of view. So I am using this Jupyter notebook. So the approach will be like this. So I just mentioned what kind of random numbers are available here, and what I will do during the course of this video, that I'll be using each cell as kind of a small hint or tips or a programming code to generate the random numbers of different types, like integers, float, how you can generate 1D arrays or 2D arrays, and so on. As it goes on, you will see later on. So random numbers in numerical Python or in NumPy, to generate the random numbers, NumPy is offering a dedicated module which is called random. Yeah, so once you have your NumPy and all other libraries installed, then we can use that. So one can generate random numbers of different types, like integer, it could be float, and arrays. So we will start first of all with the random numbers of data type integer. So how we can generate random numbers of data type integer? So first of all, we'll start with the convention that we will import the random number module by using the NumPy library. So from NumPy, import random, and then we will say we will initialize a variable, and x equals to random dot rand int. So it's a random number of integer type, and then we say we wanted to have random numbers of let's say value of 20, and then let's print this value, and you see it's giving from 0 to 20 it will be generating, keep on generating random numbers within the value of like 20. So you can even decrease that, for example, to 10, and then you keep on executing this cell. And by the way, just for your information, I'm using Control plus Enter on your keyboard, a shortcut to execute the current cell, and it will always reside in the same cell, so it will not jump over to the next cell, which is another command that is like Shift plus Enter. So you see you always getting a different number. So in order to make it things more fancy, we can say random integer value is okay. So random integer value is 8, now random integer value is 1, so and so on, and so it really goes on. So this is how you really generate random integers, and now we can also demonstrate how to generate random float values. So once again the same procedure, and then we will say x equals to random dot it's called now to, in order to have random numbers of type float, we will use let's say a rand function, and then you go out to print this value, and then you once again say that random float value is x. So random float value is 0. So it's giving you a float value, right? So you can even change this. So by default, if you do not give any input value, it will be taking between 0 to 1, 0 and 1. So you can even give other than 0 and 1, just 2, and once you execute it, you will get then 2 values. So if you do not use any value in between, if you say even 1 and you just execute the cell once again, so you will get only one value, one scalar value or a float variable. So this is how you do normally the random float variables, and then you will move on to how you can generate random 1D arrays. So we'll be using once again the same convention. You import your random module, and then we will say x equals to random rand int, and then I say I wanted to generate a 1D array of random numbers up to 100, and I wanted to give a size of about 3, right? So what will happen now is you will see that if I print x, so now I'll be getting, so the size actually it tells you the shape of an array, right? It will be telling you the shape of an array, if it's a 2-dimensional, if it's a 1-dimensional. So remember that size always tells you the shape of an array. All right, now we have seen how we can generate 1-dimensional arrays. So we will use a similar procedure. Let's copy this block of code and we will paste it into random 2D arrays, and then I will say 100, and now I want you to say I wanted to have a two-dimensional array, so I'll be having three columns and let's say 5 rows, or 3 by 5 you can say. So let's say I will say now I will use parentheses 3, 5. Now if I execute this one, so you will see that now I will be having 3 rows and 5 columns. So it's remember, once again, as I already mentioned, that size is it tells you the shape of your array. So if it is 1-dimensional or 2-dimensional. So if you wanted to have a random number generation of a 2-dimensional array, and then we will be having, so it's 3 by 5, so we have 3 rows and 5 columns, and we have mentioned maximum of random number generation within the range of 100, so you can even reduce that. So I would say even 50. Then you execute that, you will see it plays from 49 is the maximum, and it's the smallest one is like 1. So from 0 to 49 or 50 it will be generating all these numbers, right? So this is how you generate different arrays. And then there is another way or another technique how you can generate your random numbers or get your random numbers from an array. Okay, so what we will do now in that case, it's almost kind of almost a similar way of approach doing it, but we will be using a different functions now. So what we will do is we will copy the same set of block once again. So we will say now in order to get your random numbers from a defined array, we will be using a choice function. It's called choice, and then we can have an array which is of any desired size. You can define that array. So let's say we will define an array of about 2, 4. These are the elements of your array, 8 and 10. So, and once again, if I print x, so I will say the random numbers. So to make things more fancier, the random numbers from an array are like this, right? So the random numbers of an array are like 2. So it will be keep on generating from your defined array these the random numbers. Okay. So this is something you can say in order to get just one number from your defined array. And also you could, if you want, you can also generate the similar kind of code for a two-dimensional stuff. So we can also change this in such a way that I will say, okay, I'm using the same array, but I would like to have now a two-dimensional value. So I would say size. Once again, remember, it defines the shape of your array. So I will say the random number generated from an array are now this one. Okay. So this is how it really works. So you can say we have 1, 2, and 3 rows, and then we have 5 columns. And the numbers, the random numbers, they are repeated with the values which we have defined in our array. So you can, even if you want, you can change that. You can say 0, 1, 2, 3, 4, 5, 6, and so on, whatever. So if I generate it again, so then it goes from minimum 0, maximum will be the number 5, which is defined in our array. And this is the way we have a two-dimensional array of having 3 rows and 5 columns, and the repeated elements will be generated randomly in your array. Okay, so we'll move on to the next step. So the random data distribution. Now, how you can generate 1D arrays, let's say containing 30 values. It could be any, I just used a random number. So we can then once again use the same convention. Just import your module and all this stuff, and then in order to generate 1D arrays containing 30 values, for example, a random data distribution, one has to really make sure there is now an addition of another important parameter, which is called probability. It will be used as P. So in addition to the choice function, which we have used earlier, which we have just used here, so the choice function. So what we will now here use it that one has to make sure, so I'll just put on a comment here, that make sure the sum of all the probabilities should be 1. Okay, so now we go on to generate this number. So I will say choice, and then we will define our array. So it will be like 2, 3, 7 and 8. You can choose any number, and as mentioned, we will now use another parameter which is called probability. So it will be P equals to the sum of the probability values of each element of an array. There are 4 elements in our defined array, 2, 3, 7, 8. So if I say 0.3, the next one is 0.2 or 3, so we have in total now 0.6. so I will say 0.2 and 0.1. so there is a probability of 0.3, 0.3, 0.2, 0.1. so if you do the total, it will be like 6, 8, 9, or we can actually change, so just to have 0.2, and we will be using now our size of 30 values. There is an error. Why? Because we don't use the comma. So okay, now we just print out, so we will see that it has given us the values of maximum of it's like 30, so it's giving us repeated random numbers but from our defined array. And one has to make sure that the probability, that the summation of these elements is actually equals to 1. Okay, so once again we can also generate another same kind of a set of random numbers, but now not for 1D, but you can generate it for 2D array. So if I just copy the same code, I just can add here, instead of using this 30 values or array of this, I will say okay, now I wanted to have 3 by 5, so 3 rows and 5 columns. So give me the values. So it will give you now a 2-dimensional array of having 3 rows and 5 columns. So this is how you generate your 2D arrays with the use of probability by using the choice function. So if you've already given an array, how to generate your random numbers from an array, this is the way to do it. Okay, so then we move on to another very important I would say functionality, which is random permutations. So what is actually permutations? So permutation is nothing, it's just a rearrangement of your elements of an array. Like for example, if you define an array with elements of A, B, C, D in your sequential order, and by using the permutation you will just shuffle or rearrange these values. So numerical Python is offering or providing 2 different methods. One is called shuffle, the other one is called permutations, to have random permutations using the random module. So you can rearrange any elements, array elements, using shuffle function of your random module. And how do you do this? We simply say from NumPy import random. We have done that. So now if we say in order to now further generate any array, I will be using the NumPy library. So I will say import NumPy as np. All right, okay, so let's say I will generate any data. So np.array. So in order to generate an array, it is a simple function available in the numerical Python library. So I will define an array of about 2, 3, 5 7, right? So now once I have defined my array, so just remember a permutation is a rearrangement of your array. So I have defined an array in this order 2, 3, 5, 7. So I will be using now a random shuffle function, okay, and I will want to shuffle this array, which is called as data. Okay, so once you will do this, and then after that I will print my data or data set, which is the name variable, which is data here, right? So I will say data. So you just press Control Enter. So see, it has now changed the order, or it has reshuffled, or it has just rearranged the values. The elements, the values of the array elements are the same, but thus they are not in the same order. So this is how you do the permutation. Okay. So now we will move on to the next step, which is how to perform array permutation. So how you can actually do that array permutation. So once again, we will import the same set of block because we will just need some few adjustment or minor changes to execute the array permutation. So we will just define an array which is of let's say this element. We can increase that 11, 13, go to 15, and then instead of using a shuffle, we will use a permutation command, which is, you can say, I mean, this is really good with the Visual Studio course. The moment you wanted to start or type any function, because Visual Studio Code uses this IntelliSense function, so it really gives you this automatic options of choosing the required function. So the moment we will generate now this print data, so we can see now that it is giving us this value. So if you just say random permutation, so it's like 2, 3, 5, 7, 9, 11, 13 and 15. This is how we can generate that different values. So this is how now we can use the permutation function. Yeah. There is one mistake here, because we need to make sure, because we wanted to change the value of x in this case because it's a permutation. There you go. So by using the permutation we can directly, so we can change the value. Once we define this random permutation, we take the permutation of our defined array with the variable name data, and then we will print the x value. So after permutation, so then we will end up getting a random generation of the same element as we've defined here in our array. Okay, now we will move on to a very important portion of this video, which is Seaborn. Seaborn is a library that uses matplotlib.pyplot to plot graphs. So it's really used to visualize random distributions. So how you can install that, as mentioned in the start of the video, you can install Seaborn using pip install Seaborn, and use then import Seaborn as SNS convention. So for the matplotlib library, we will be using the import matplotlib.pyplot splt. So I will just try to demonstrate how you can simply use that. So the very first one will be like how you can generate distribution plots using histogram. So we will be plotting our curve shape, and plus including how it looks like in the form of an histogram. So how we start with this kind of set of codes? First of all, we will be importing our matplotlib.pyplot splt. Second one will be import Seaborn as SNS. All right. So once we have done that, so what we will use is, then we will be using an SNS dot distplot. So distplot means distribution plot. So what we will do is that I will be then using, let's say, an array. It goes from 0 to 2, 4, 6, 8, 10, 12, 14, 16, 18 and 20 set of values. And then I will say I will want to have a color of value blue, for example. And then to plot this using the matplotlib library, we will simply use a plt.show command, and then by using control plus enter we will execute this. Yeah, you see it's running. It's trying to load the libraries in the background for the first time when you will do that or initialize that. So this is really a very nice plot. You can see that it's a distribution plot using a histogram. So we can also enlarge this one. If you just click on this expand image, it will open a new tab, and then in order to analyze this plot you can just simply make it a little bit bigger. So you see this very nice plot. So it goes from, this is your x-axis and this is your density. If you want, you can do the labeling, or x-axis your desired names. You can give a title, you can change the color of. If you also want, you can disable this histogram that I will be demonstrating immediately after this code. There are also, remember, other ways, other functions to plot this one, because if you see this warning message, it's saying that distoplot is a deprecated function and it will be removed in a future version. So please adopt your code to like displot or other hisplot functions to plot that. So if you want, you can also try this one. So if you don't want, let's say, an histogram in your plot, so you can even say hist equals to false, and I think then it's good to go. You can use that. So we have used 2 commas. This should not be a problem. So now we see we have the same plot, but we don't have an histogram inside. So by default it's set to true, this hist option or a histogram option. So this is the way we can generate a distribution plot using hist or histogram. So there you go. I think this is quite a good way of generating a different set of arrays. So even without an array, you can also generate that, but you can even use different variables or different functions like random numbers, again random function, to generate the value, which I will demonstrate it later on. So I would like to actually demonstrate this here, like a distribution plot without histogram. So but I have just shown you here this option, which is actually the same, but as just to have the formality, I will just copy this code and show you guys how you can generate that. Right, so you just have a histogram, which is, if you set it to false mode, you will get this value. So we can even generate a different set of values even to generate this, and also you can have different colors. So you can generate a different color. So you will get this green value, and you can do really nice things where you, with the help of your X label, for example, X label, you can give a value which is called X, and then you can even have plt dot y label, plt dot title. So you could even say distribution plot without histogram, and now you will execute this one and you will see that it is showing you your desired value. So if we just try to make it a little bit bigger, we drag it and just center it, you see this is our given title, and these are the X and Y labels, so X-axis and also on the Y-axis. So there are lots of cool stuff which you can actually do with the combination of Seaborn and matplotlib libraries. So we will move on to the next important part, which is the normal distribution, so or Gaussian distributions. You can use the random normal method in order to get the normal distribution, and it has actually very important 3 parameters. So one is the first one is the LOC, so loc, which is like the mean value where the peak of your bell exists. So if you, just to demonstrate or just to give you an idea, for example, this is the peak value of our bell-shaped curve. So you can define your loc value where it to be. You can say loc equals to 0, loc equals to 1 or 5, and then we have a scale, so standard deviation. How flat you wanted to have your graph distribution it should be. This we will see later on when we will compare 2 different types of functions for the same data, how the scale function helps to get a direct comparison. Size, it once again it is the shape of your returned array, right? So this will be telling you the shape of your returned array. So now to how to generate a random Gaussian distribution, how we can do that. So first of all we will be importing our matplotlib.pyplot library, and then we will import Seaborn as SNS, right? And now in order to proceed further onwards or to generate a random Gaussian distribution, I'll be using 2 different plot types of SNS. So first of all I'll be using SNS.kda plot. So and we will be generating simple random numbers of type normal. So I've already mentioned here random.normal method to get your normal data distributions, but 2 different plotting functions. So first I will be using KDE plot. Another good function, if you just hover your mouse over KDE plot, so it will give you the options which are really available to get to plot this one. These are the input arguments which you will utilize or used to plot your variables. So we will be starting with a random number of type normal, and we will say it has a loc or a mean value of a location of 1 at a value of 1, and it has a scale of 2, and then a size. Remember, it's once again the shape of your returning array, so it's a 1-dimensional array in this case we are using. And then we wanted to plot against not KDE plots this time. We wanted to use for example dist plot. So we will say random dot normal, and this time we will say loc equals to 1, scale equals to 2, and size, because due to the nature of this function you have to give it as a 2-dimensional array. So once you are done by doing this one, just to make things more better, so I will say for the KDE plot, color equals to green, and I will give it a label KDE plot, right? And here once again we will say color equals to blue, and we will say a label of this plot. Now in order to activate these labels, we will use a command which is called plt.legend. Yeah. And then to plot that we will be using plt.show. So control plus enter, execute this, and you will see now you are getting your histogram values including this curve. So as already shown earlier, I think it's much better if we just turn off the histogram in order to get a better comparison, to see that hist equals to false. So now this is the way. So now we can see, we can compare them much better. So let's open it in another separate tab, and zoom in a little bit and just centralize it a bit. So there you go. So the green one is the KDE plot. Remember we said, and this is the disk plot, and we have mentioned a maximum peak which is about around 1, so we can get our location, desired location, which is about 1 for our value of an array. This is how you can compare two different type of plots, even in that case a different set of random elements which we have generated. So this is how you actually can generate a random Gaussian distribution by using two different types of SNS function. One is the KDE plot and the second one is the disk plot. So distribution plot using histogram or without using a histogram. So okay, now move on to the difference between this is very important. Normally when you are having a data available and you wanted to just plot the differences between two different types of functions or methods for your let's say even a normal Gaussian distribution, or you have a logical distribution which is called, sometimes it is denoted as a logistic distributions. In actually these both types of distributions are almost identical, but we will see just very in short that the logistic distribution, normally it covers more area as you approach towards the end. Let's say as you approach towards the end, if you see this curve here, the blue one or the green one, as you approach towards the end, the logical distribution will cover more area. That is, the logistic distribution predicts more possibility of your event occurrence. Yeah, as you move further away from your mean value, yeah, of your peak, as you keep on moving away from your peak, so it will cover more area. So for higher value of scales or standard deviations, the normal logistic distributions are almost near identical, except for the peak values. So let's start and let's demonstrate how we can plot this one. So once again we will use the same approach. matplotlib.pyplot, and then the last one, Seaborn SNS. Alright, so now we'll be using sns.kde plot, and I will be generating random, normal. So let's say we'll take a scale of 2, size of 1000 for a KDE plot, and so 1000 let's say, and I will be using a color of blue, and just give it a label normal. So let's say this to make it quick, let's copy this, because now we'll be using just a different random method which is called logistic. So logistic, so let's use green, and we give the label once again the value which is called logistic. Okay, so we will say plt.legend. So we plus control plus enter, and we end up getting this curve. So what we see from here, as mentioned earlier, that actually they are almost typically the same. The differences are coming in the peak values, but as you move towards the end, it kind of predicts more the logistic one, which is the green one. We can have a much better comparison if we go there now. So you see, this is the peak value. So there is a variation, or there is a difference in the peak values, but as you go further down or away from the peak values, the green one tends to cover or predict the occurrence of probability or of your event more towards the end compared to the normal one. This is what I just wanted to show you or to demonstrate. Let's delete this one, just remove it from the resident part. Alright, so now we'll move on to the, I hope it's the last part. So the uniform distributions. The uniform distributions, it can be referred to as, or it is often used normally to describe the probability where every event has equal chances of occurring. So there are three parameters. So A, which is the low bound, default value is 0, and then you have B, which is the upper bound, has default value of 1. Size, once again, the shape of your returned array. So how you can generate this type of distributions? So we will say from NumPy you import random module, then we will move on further. We import matplotlib.pyplot as plt, then you import Seaborn as SNS. Yeah, once again we will be using two different types of plots. First of all, I will just to demonstrate this plot, we will use random uniform method because we will be generating uniform distribution. So size of about 15 and color equals to, let's give it green, and SNS we will be generating a KDE plot. Random uniform, size equals 15, and color equals to blue. Control plus enter, and we can see this is how you can generate a uniform distribution of random numbers by using two different plotting functions available using Seaborn. So this is just not all, there are also other functions available from SNS, like the one, for example, this plot is a deprecated function, as already mentioned or seen before. There is a warning. You can use this plot, you can use his plot. So even just to test, you can, instead of using this plot or KD plot, you can use this plot to have a figure level function with similar flexibility, or you can also have a his plot to use an axis level function for your histograms. So for your histogram you can use this one, and for this plot you can plot this curve and also compare it with KDE type of plots. So I think this is almost it from today's video. And just to have a recap what we have just done, so we have just seen that how you can define random numbers, how you can generate random numbers of different types, like random number of integer types, of random number of type float. And then we have seen how to generate one-dimensional arrays, two-dimensional arrays of random types, and how we can generate random numbers from a predefined arrays by using the choice function. Then we have seen the random number data distribution, so 1D array containing different values, and then how to use choice function together with probability to generate a 2D array. This is the one, and make sure that's why I've mentioned here that the probabilities, all the probabilities should be 1. And then how you can perform the random permutations using shuffle and permutation methods with the use of random module. And then we have at the last we have seen the combination of Seaborn and matplotlib libraries to really do a very powerful plotting of different natures, and you can combine different plotting techniques, and you can have different random number distributions like Gaussian distributions, or you can plot distribution plots, have distribution plots using histograms, without histogram, and also how you can have a difference or comparison between different types of distributions. For example, we have seen the difference between normal and logical or logistic distributions, and finally we have also seen how you can plot the uniform distribution using the Seaborn plotting library together with the I would say matplotlib visualization library. So at this point I will finish off my video, and I will encourage you guys to give me your feedback and subscribe my channel if you have not done until now, and press the bell icon so you will be having all the notifications of my new upcoming videos. And if you want me to do any video which you think it could be really useful, just let me know and give me your feedback, and share my channel among your friends and family members if you think that it's really informative and it is really helpful, and I need the support of you guys. And take care, have a nice day, thanks for watching, and keep watching my channel. Bye bye.